This class we discuss about resonance frequency is the geometric mean of the F1 and F2. F1 is the lower frequency, F2 is the upper frequency. We know that omega 1 is equal to minus r by 2l plus root of r by 2l the whole square plus 1 by LC. Omega 2 is equal to plus r by 2l plus root of r by 2l the whole square plus 1 by LC. Let alpha is equal to r by 2l. Omega naught we know 1 by root LC. Omega naught square is equal to 1 by LC. Substitute alpha and omega naught square in these two equations. We got omega 1 is equal to minus alpha plus root of alpha square plus omega naught square. Omega 2 is equal to alpha plus root of alpha square plus omega naught square. Multiply omega 1 and omega 2 and simplify it. We got omega 1 into omega 2 is equal to omega naught square. Omega naught is equal to root of omega 1 into omega 2. So omega naught is equal to 2 pi f naught. Omega 1 is equal to 2 pi f1. Omega 2 is equal to 2 pi f2. So 2 pi f naught is equal to root of 4 pi square into f1 into f2. Simplify it. F naught is equal to root of f1 and f2. So f naught is the geometric mean of f1 and f2 are lower and upper frequency. The next is relation between omega 1, omega 2 and bandwidth. Quality factor Q naught can also be defined as the ratio of resonant frequency omega naught to bandwidth delta f. Q naught is equal to omega naught into L by R. You know it. I rewrite the equation. R by L is equal to omega naught by Q naught. I substitute omega naught by Q naught in the two equations. Omega 1 is equal to minus omega naught by 2 Q naught plus root of omega naught by 2 Q naught the whole square plus omega naught square. So omega 1 is equal to minus omega naught by 2 Q naught plus omega naught into root of 1 by 4 Q naught square plus 1. If Q naught is greater than or is equal to 5, so 1 by 4 pi plus 1 is equal to 1. Here omega 1 is equal to omega naught, this is 1 minus omega naught by 2 Q naught. Here Q naught is equal to omega naught by omega 2 minus omega 1, that is equal to omega naught by delta f. I rewrite bandwidth is equal to omega naught by Q naught. Therefore, I can write omega 1 is equal to omega naught minus delta f by 2. Similarly, omega 2 is equal to omega naught by 2 Q naught plus omega naught root of 1 by 4 Q naught square plus 1. Again, this value is 1. Omega 2 is equal to omega naught plus omega naught by 2 Q naught. Again, omega 2 is equal to omega naught plus delta f by 2, that is bandwidth by 2. This graph shows the relation between frequency and current. Here the black curve indicates very low L by R ratio. Blue curve indicates low L by R ratio. Green curve indicates high L by R ratio. This is the relation between omega 1, omega 2 and bandwidth. And f naught is equal to root of f1 and f2 is the geometric mean of f1 and f2. The last term is selectivity. Selectivity of a resonant circuit is its ability to discriminate signals of desired and undesired frequencies. Selectivity is equal to resonant frequency Fr divided by bandwidth F2 minus F1. F2 minus F1 is equal to R by 2 pi L. The sharpness of tuning depends upon the ratio of R by L. A small ratio indicates a high degree of selectivity. A good selectivity implies small f2 minus f1 or a large value of q, that is quality factor, which means that the coil has large inductive reactance XL compared to its resistance R. For a series RLC circuit, selectivity is equal to quality factor. Q is equal to 1 by R root L by C. High value of Q has a much sharper peak and therefore has a greater selectivity. The current magnitude of high over a small range of frequencies. The selectivity of our resonance circuit depends on L by C ratio. In a nutshell, resonance frequency F0 is equal to root of F1 into F2. F1 and F2 are the upper and lower half hour frequencies. And the relation between bandwidth omega 1, omega 2 and omega is equal to omega naught is equal to omega 1 is equal to omega naught minus 1 by 2 into bandwidth. Omega 2 is equal to omega naught plus 1 by 2 into bandwidth. With this, I conclude my lecture. Thanks for listening.